Do you know how many participants?
Yeah, currently we have 55, so we can start another 5 minutes or so. Exactly, we can start at 6:30.
Okay.
Another 4 minutes we can wait for.
Mhm. So we have a 4 years and a half of difference between Italy and India now. Welcome to my students attending the webinar. I
Yeah,
see
yes,
their
sir.
names.
I have seen your students are joining. Thank you. Thanks for circulating the posters. Yeah, we have a good number of participants. So
Will
currently,
you say some words at the start?
Yes, sir.
yeah,
So we are going to
Okay.
start it in a formal way. We'll be introducing you
Okay.
in just a minute, I think.
yeah, I think Maina
Yeah.
is there.
Yes,
Madam,
sir.
hello?
Yes, sir.
Yeah, please, I
Yes, sir.
think
Shall
we'll
we
start
start?
now. Yes,
Sure.
yes, please go ahead.
Okay, sir. A wonderful evening to all of you. Learning never exhausts the mind. Yes, with this passion for learning, we've all gathered here this evening, ladies and gentlemen. Myself, Dr. Maina Ayan, Associate Professor and Head, Department of Computer Science and Engineering, Naukis College of Engineering, Hassan, Karnataka. Welcome you all to the webinar on ecological reconversion of cars, the case of solar hybridization, delivered by Dr. Gianfranco Rizzo, Professor, Department of Industrial Engineering, University of Salerno, Italy. This international webinar is organized by IEEE Mysuru subsection in association with IEEE Bangalore section and IEEE Information Theory Society Bangalore chapter. The topic chosen is highly relevant in this current scenario. Now I request all the participants to stay muted for the smooth conduction of the event. Also, I request all the participants to mention their name with proper initials and mail ID, which will be considered for attendance. Let me now give an introduction about IEEE Mysuru subsection. IEEE Mysuru subsection, installation one among the 3 subsections of IEEE Bangalore section. The aim of IEEE Mysore subsection is to conduct various student and professional activities like invited talks, student internships, workshops, and the flagship conferences. IEEE Mysore subsection consists of Mysore, Mandya, Hassan, Chamarajanagar, and Kodagu districts. Mysore subsection has 26 engineering colleges with 14 IEEE student branches and more than 1,000 IEEE members. IEEE Mysore subsection will enhance the professional networking, humanitarian activities, staying updated with latest technological development. IEEE Mysore subsection was inaugurated by Ms. Susan K. Land, IEEE President, USA 2021 on 21st December 2020. IEEE Mysore subsection was initiated by Mr. Puneet Kumar Mishra, Chair, IEEE Bangalore section. The event was graced by the presence of key leaders of IEEE Region 10. Nomination Committee Chair for IEEE Bangalore section, Mr. Keshav Bapat, presented the slate on IEEE Mysore subsection as follows. Chair, Dr. Bindu A. Thomas. Chair-elect, Dr. Paramesh Achari BD. Vice Chair, Dr. Sudarshan Patil Kulkarni. Secretary, Dr. Radha Krishna Rao KA. And the Treasurer, Dr. Archana NV, along with 17 Execom members for IEEE Mysore subsection. The goal of IEEE Mysore subsection is to conduct various flagship events, outcome-based programs, and various technical activities. I am truly privileged to talk about the legacy of IEEE Mysore subsection. Now, I request Mrs. Namrata D. Cruz, Assistant Professor, Department of ECE, VVIET Mysuru, and IEEE Execom member to present the welcome address.
Good evening, everyone. Am I audible?
Yes, you are.
A very pleasant evening to all. It's my immense pleasure in welcoming you all for the webinar on Ecological Reconversion of Cars, the Case of Solar Hybridization, organized by IEEE Mysore subsection in association with IEEE Bangalore section and IEEE Information Theory Society Bangalore chapter. It's an honor to welcome the resource person for today's webinar, Dr. Gianfranco Rizzo, Professor, Department of Industrial Engineering, University of Salerno, Italy. On behalf of IEEE Mysore section, I extend a hearty welcome to you, sir. I extend a warm welcome to the panelists, Dr. Bindu A. Thomas, Chair, IEEE Mysore subsection, and Dr. Paramesh Achari BD, Chair-elect, IEEE Mysore subsection for today's event.
Thank you.
I cordially welcome the organizing committee, all the Execom members and coordinators for the webinar. Lastly, I would like to welcome all the participants for today's webinar. Thank you.
Thank you, Namrata. Now, I would like to introduce today's speaker to the audience. I'm honored to read a brief profile of Dr. Gianfranco Rizzo. Dr. Gianfranco Rizzo, Professor, Department of Industrial Engineering, University of Salerno, Italy. He was the Chair of Mechanical and Management Engineering at University of Salerno during 2011 to 2019. He was the Chair of Technical Committee, Automotive Control of IFAC during 2008 to 2011. He is the Associate Editor of Control Engineering Practice, Board Member of International Journal of Energy Optimization and Engineering, International Journal of Powertrain, Titao Masters Academy. He is the International Advisory Board Member of Combustion Engine Research Center, Commerce University. Member of the Italian Committee on Renewable Energy at the Federation International delle Automobile during 2015 to 2017. He was the member of Committee Region Campania, Italian Space Agency during 2016 to 2017. He is the founder of eProIn, Energy and Propulsion Innovation, spin-off of the University of Salerno in 2014. He is also the founder and CEO of ePowering, spin-off of the University of Salerno in 2019. He is the member of the Committee for the National Research Program on Sustainable Mobility. Dr. Gianfranco Rizzo is also the recipient of several prestigious awards. He is the recipient of Guangzhou Award for Urban Innovation in 2012, second place Exico for the project Sustainable Energy Now, He has received the Seal of Excellence Award by Horizon 2020 for the project SME Instrument Phase 2 High Solar Kit. SMAU Award 2018 for the project LifeSave for conversion of cars into hybrid solar vehicles. Dr. Gianfranco Rizzo has published several research papers in various international journals. He has published about 200 papers on automotive engines, hybrid and solar vehicles, thermal power plants, renewable energy plants, modeling and optimization of bioeconomic systems. He has around 330 citations. He has published papers in journals which have H-index of about 12. He is responsible for various research projects with EU, industry, and government. It's a privilege for me to introduce such an eminent speaker to the audience.
Hello.
Now, we shall start this session. I request the participants to drop their doubts in the chat box, which will be taken up soon after the completion of the presenter's talk. So, a link will be provided in the chat box. Kindly provide your valuable feedback, which is mandatory to get a certificate. Now, I request our chief guest, Dr. Gianfranco Rizzo, Professor, Department of Industrial Engineering, University of Salerno, Italy, to take over the session. Over to you, sir.
So, thank you very much for your kind introduction and for inviting me. So please, it's better to stop microphones if we have not to talk to avoid echoes. So I would share my screen. Starting with my talk. So the title is Ecological Reconversion of Cars, the Case of Solar Hybridization. And I will present some results relating to a project I'm working since some years. And a few words about the university I work in. Is located in the south of Italy, in Campania region. This is a look to the Salerno. Salerno hosted the most ancient medical school in Europe about 1,000 years ago. Now it has a quite large, for Italian standards, university, about 40,000 students, a very large campus. And in last years, the university are reaching good results also in the international ranking compared to other universities. During last years, we have also good performance in terms of innovation and in number of innovative companies like academic spin-off in the region, in the province of Salerno. So this is a look to the research activities in my group. My group works mainly on automotive engines, powertrain, also conventional energy technology like fuel cells, hybrid vehicles, and we have some experimental facilities and some prototypes. And this is a look to some of our partners. Also, we have some partners in China, in Italy, in the United States, in Canada. We work in several topics related to energy and propulsion. So just a few words to introduce the topic of my talk. The topic is, as you know, transport, which is one of the major issues for this slide refers to Europe, but is a major issue for the world. And these are some figures relating to the impact of CO2 emission for transport and passenger cars. And everybody knows that we are facing a very serious problem due to the CO2 in the atmosphere. And in the last decades, CO2 concentration is reaching some values which are never been reached since the human life was not in the earth. So it's a very, very serious problem. It's a serious problem, but it's not a new problem, because almost 100 years ago, a New Zealander magazine was alerting about global warming due to CO2. So it's not a new problem. And also in last year, we have some additional problems which made this problem even more serious. One is due to the effect that the global warming may have on the Earth due to possibility to could unleash some viruses, and also there are some evidences that urban pollution may aggravate the virus infection due to transport of a virus. And also, it's reasonable that due to the constraints, there will be a greater use of private cars for personal transportation in next future. And finally, we are facing a very, very serious economic crisis, and so we need reasonable and affordable proposal aimed at the majority of people in the world, not only in rich countries, able to create job opportunities. So, looking at the categories of sustainable mobility. So please, I hear some voice. If you can cut off the microphone, please. There are two categories of sustainable mobility. One is, of course, electric vehicles. And the most common solution is the battery electric vehicle, an electric motor which may reach quite high efficiency, is fed by a battery, moving the wheels. And other solution is the fuel cell electric vehicle. In this case, the electric motor is fed by the current generated by a fuel cell fed by hydrogen. And these are very, very clean solutions, but there are some very positive aspects relating to pollution-free at low noise, but there are also some negative aspects relating to the fact that a large amount of carbon-free electricity would be needed to feed batteries. And the electric vehicles, because of the battery limitation, have some limited range still. There are some cost and life issues of batteries. There is no free heat energy on board, unlike happening with thermal engine, where there is some free heat available. And there are some serious recharging issues for these electric vehicles. This is just an example. This is the classical tools for recharging the batteries. They range between 3 to 22 kilowatts and fast recharge reach and 100 kilowatts. But if we are going to calculate how much energy enters in a unit time in an internal combustion engine, we reach almost 10 megawatts. So it's 100 times greater than the power of recharging electric vehicles. So is still a big gap to be overcome. So we may say that mass car electrification is the future, but it's not behind the corner, speaking about mass car electrification. So as it often happens when there is a transition between the new from old to a new technology, there is a gradual transition with some hybrid in behind. So also when ships passed from sailing to steam propulsion, for a period, these two technologies coexisted. And also motorcycles maintaining pedals for assistance in climbing in first years. So also for cars, electric hybrid cars were combining internal combustion engine with electric motor and generators. The idea is not new. The first hybrid car was born in the more than 100 years ago by Lohner Porsche. This is a picture of this car. Now the hybrid vehicle market is growing fast and is anticipated of an annual rate of growth of about 16% during the period from 2020 to 2025. And so going to hybrid vehicles, there are different technologies. One is the architecture of a parallel hybrid, where the electric motor and the engine may cooperate to move the wheels. So going in parallel. While the other architecture, less diffused, is a series hybrid, where in this case the electric motor alone moves the wheel and the engine recharges the battery by means of an electric generator. And a special category of a parallel hybrid, which is strictly related to our case, is the parallel through-the-road electric vehicle, hybrid vehicle. In this case, the engine and there is two wheels moved by electric motors in the wheels. Mm-hmm. And other two wheels are moved by the classical internal combustion engine. So the mechanical coupling between these two is made by the road. So the name is through the parallel. And finally, we have the plug-in hybrid electric vehicles, which may be recharged both by the internal mechanism, so by regenerative braking, by the engine itself, and by the electrical net. Also, in this case, we have some positive and negative aspects for hybrid. They have a lower emission compared to internal combustion engine vehicles. They have an extended range, so they don't suffer of the range problems of the electric vehicles. But also, in this case, some carbon-free electricity is needed for recharging from the net. There is still an issue relating to cost and life of batteries, if less strong than in electric cars, and they have no zero emission. And this is, of course, we could speak a lot about hybrid. In this seminar, we just can give some few information. One of the key parameter to classify the hybrid vehicles is the degree of hybridization, which is defined as the ratio of the maximum power of electric motor over the sum of the maximum power of the internal combustion engine and of the electric motor. So this ratio may range from 0 to 1. 0 means we are the classical thermal engine, and 1 is the electric vehicle. In the between, we have a large range of hybrid. And we can also say that only the vehicles with enough degree of hybridization reach the real benefit of a hybrid, while all these vehicles are called a hybrid. This is another problem. Be aware that we can call hybrid also a vehicle with a very few features of hybrid vehicles. But in order to substitute the conventional car with electric or hybrid vehicle, we should do a massive disposal of the actual fleet. And this is not a sustainable perspective for a number of reasons. So there is also another possibility to convert the vehicle. One is the first conversion that has been diffused is the electrification, which consists in removing the internal combustion engine and installing an electrical powertrain. And some specific regulations have been introduced in Europe by Italy and France. Hybridization consists in adding an electric powertrain to a conventional vehicle, so it becomes an hybrid vehicle. In this case, the first country in the world to introduce a specific regulation for hybridization was India. And in last month, Italy introduced a law allowing the conversion of hybrid vehicles, of the vehicles into hybrid as the first country in Europe. So our proposal deals with converting conventional cars into hybrid and solar vehicles, and I will talk about this. So the conversion will be done as is shown in this short video by adding some electric motors, some panels, and an additional battery. So wheel motors are added in the rear wheels, while the front wheels are moved by a thermal engine. An additional battery is placed in the vehicle, some photovoltaic panels, an onboard control system, and this technology has been patented by the startup that I and some colleagues of mine have founded at the University of Salerno, IPROIN, and by some partners working with us in the projects. The benefits: the reduction of fuel consumption and emission may reach even 20–25% in the best conditions in the typical urban driving, say driving for 1 hour per day in a sunny day, with possibility for recharging for free with the sun. And associated with the lower usage of internal combustion engine, of course, there is a lower emission, almost proportional to the reduction in fuel consumption. with the possibility to drive with only the electric motors in controlled traffic zones, so with zero emission driving. The range is extended also with respect to conventional cars, because we don't eliminate the thermal engine, but we add some motors with a battery, so the range is extended, and also there is an advantage in performances, higher torque, particularly enhanced acceleration, because we have electric motor in the rear wheels, and the rear wheels are the wheels that more have a greater contributed in the acceleration phase. And of course, the cost is much lower than a native hybrid, and the payback is better than a hybrid car. But there are also other aspects to be considered. This proposal complies with all major criteria of sustainability. We say the 3 R's: reduce, reuse, and recycle. Particularly, we allow reusing existing cars, avoiding fleet scrapping. And in fact, this proposal also comply with the Sustainable Development Goals defined by the United Nations, the 2030 Agenda for Sustainable Development. And most of these 17 goals are complied by our proposal. I have no time to explain in detail now, but we can talk about this also. This is the scheme of the hybridized vehicle. Front wheels are moved by internal combustion engine. There is an electronic control unit. The electronic control unit is connected with an onboard diagnostic port, and in our solution we derive this signal from this OBD port and interpreted this in a VMU, an additional vehicle management unit. And in this case, this is the addition in the vehicle. 2 reversible electric motor are added in the rear wheels. There is an electric node. There are some converters, a battery, and some PV panels, and the flow of the power is coordinated by this unit. We can also look at the classification of solar hybridized cars within the framework of the cars in terms of battery energy, in terms of degree of hybridization. We have here, this is the place of battery electric vehicles. This is the plug-in hybrid. The place of full hybrid is almost this, and this is the range of our solution. So in terms of battery energy, they must have enough battery energy to store the solar energy coming in a sunny day, so from 2 to 4, but even to 10 kilowatt per hours. The degree of hybridization is from 0.2 to 0.3 about. This is a test showing in simulation that there is a significant increase in acceleration due to the addition of two electric motors in rear wheels. And in this case, we can also avoid skidding in the front wheels due to the the cooperative of the rear wheels in the acceleration phase, particularly in wet road. So a few words about the use of solar energy in automotive. Solar cars appeared the first time in the 60s, in the 70s, due to the success of solar photovoltaic in space vehicles, and after some first very naive prototype, some very advanced cars have been developed by universities, by companies participating to the competition in Australia and in the other part of the world. There is, for instance, the Nuna developed at University of Delft, reaching a very high speed. But these cars were intended, solar cars, to be moved only by sun. This is not a practical solution for a number of reasons. And so the idea to assist the cars by the solar power gained space in the last decades. And there are some cars from Toyota, from Ford also. While recently, the idea to make some cars moving essentially with the sun also gain space. Now there are some very advanced prototypes. So speaking about the use of photovoltaic in automotive, we have first to say that the use of photovoltaic on the vehicle is the only case where the primary energy can go directly to the wheels, while in all the other cases, we have to incorporate primary energy in an energy vector, maybe gasoline, maybe oil, maybe electricity, hydrogen, by some operation like energy conversion, distribution, which give rise to consumption of energy, to give rise to emission, and of course to profit and taxes. So the only case we can use this energy from the nature directly on the vehicle is from photovoltaic on the vehicle. But unfortunately, there are some limitations due to the energy density coming in a square meter on the Earth. So if we look at the power coming, and this analysis may be discouraging, because we can see that the power of a vehicle may be, for instance, 60 kilowatts, while the power of a photovoltaic panel to be put on the car may be 0.3, 0.4, 0.5 kilowatts. So it's much less than this. But this way to look the problem is not correct, because this is the maximum power of the car. We have to consider that in average, a car is moved for many people 1 hour per day, and moves in the city, in the urban driving. If we go to simulate the energy and the power required in urban driving, which is this part of the cycle, we can see that the average power in urban driving is less than 10 kilowatts if we can recover part of the negative energy by braking. So while a photovoltaic panel may take sun or light for a long time, for even 10 hours per day. So if we consider at this point the energy consumed during the day from the car driving in a city, which is 8-10 kilowatt per hour, and compare with the energy that could be taken by photovoltaic in best condition, which may reach 2 kilowatts per hour, is the ratio 25%. So it's not negligible. And in fact, a recent market study has a growth of a very, very interesting rate of 36% of annual growth rate in the next decade. We have also made some studies in order to estimate the contribution from the solar photovoltaic panels by considering some database. Some PVWatts is an American database that consider typical meteorological years, so to take into account also the main effect of the bad weather and so on. So in this case, we have seen that considering a 2 square meter panel horizontal surface, which is compatible with most cars, maximum daily contribution can be over 3 kilowatts per hour per day in some very, very good place like in Australia. But mean contribution, also considering winter time, range from 1,000 to 2,000 watt-hour per day in most of the world places. And if we also add some panels on the lateral side of the vehicles, this value may reach maximum value exceed 5,000 watt-hours per day in most favorite places, and average contribution range from 2 to 3 kilowatt-hours per day in most places. So another aspect is considering the life cycle assessment of this system. As we know, when considering the life of a car, we have to consider the several contribution to the energy consumption and to emission coming from usage of fuel, for instance, considering all the chain carrying the energy to the car, and also all the cycle relating to the building of this vehicle and to the dismissal also. So in this case, we used a model developed by the Argonne Laboratory, is in Chicago, which has a very, very advanced database considering most of these effects, and also relating to the well-to-pump aspects from production, transport, storage on the primary energy source and the fuel. Also, the extraction, recycle, processing of the materials, manufacturing process, and disposal. And so, in this case, we considered a scenario where a person, after driving his car for some years, may decide to keep the car or to buy a new car and dismiss the old one, and taking a hybrid or plug-in hybrid or electric, or converting the car by high solar kit or by electric vehicle kit. And we published a couple of papers on this. And shortly, the results were that vehicle operation, as expected, has a major role, almost 60%, from 50 to 60%, both in terms of energy consumption and green gas emissions, CO2 emissions. But there is a not negligible contribution from the fuel cycle and from a vehicle cycle too. Vehicle cycle, which is almost is not considered in many cases, accounts for 20% of the entire process. So considering this aspect and considering then when we add a kit to a vehicle, the cost in terms of energy and emission of the kit is quite negligible compared to the cost of a new vehicle, of course. If we make the comparison of the different cases, we arrive at the conclusion that in many cases the solution of converting the car is the best solution by overall point of view, just because we strongly reduce the aspect relating to vehicle cycle. So the conclusion is vehicle conversion is a good option, both in terms of energy consumption and of CO2 emissions. So now I would show some research work done on this aspect. We first assessed the benefits of the kit for solar hybridization by simulation studies, by building some MATLAB Simulink model of a conventional and the vehicle equipped with this kit. And the main results were that driving distance and type, urban versus highway, and the availability of charging infrastructure is an important role in the fuel economy of the vehicle. And the solution without PV panels results in higher payback time for any in-wheel motor considered. So it's worth to use PV panels. And there is a significant reduction in fuel consumption and CO2 emission, up to 20% in selected configuration, comparable with hybrid benefits, but at a lower investment cost. We also studied some aspects relating, for instance, to effects of the actuation delays in the hybridized vehicle. We studied how fast must be the actuation in our kit in order to make the vehicle drivable, and we verified that with used actuation delay, we have no problem of drivability in the vehicle, while there is a limit in the adoption of a power split. Power split is the fraction of the power that could be given by the electric motor. In this case, power split could not exceed 0.7 or 0.8 for the reason of drivability. We have also tried to optimize the control schedule of these vehicles. We have first done this with dynamic programming tools in order to achieve some offline picture that give the benchmark of the benefits that could be obtained in online. And also in this case, we have confirmed that benefits may reach 20% in best cases, and a bit less in some real cases. Finally, we have also used some other optimal control strategies. This is a very recent result published in the PhD thesis of Francesco Tiano, which is one of my colleagues who worked in this work also with Matteo Marino. Both of them are attending to the seminar. We used the well-known Pontryagin minimum principle and the equivalent consumption minimization strategy, which are very popular ways to optimize the control in a hybrid. And we confirmed that, particularly in case of use of the vehicle in charge depleting mode, which is typical of the vehicle used with solar energy, we may achieve some interesting reduction of fuel consumption comparable with those of some hybrid vehicle. Finally, we are also studying the aspect relating to optimizing the regenerative braking, because when we hybridize an existing car, the electric braking may coexist with mechanical braking. So in this case, it's important to modulate in optimal way the electrical braking in order to achieve a safe braking maneuver. The classical braking maneuver only with mechanical braking is given by this black line. By adding some electrical braking, we may act in this region, and this other is the safe region without within grip limit. So we also developed a study in order to modulate in optimal way the braking, and we demonstrate that quite interesting rate of recovered energy may be reached, almost 40% of the kinetic energy of the vehicle, by adopting some advanced technique to regenerative braking. Finally, we have also studied some thermal effects in PV panels on cars, because the use of photovoltaic panels on cars is quite different from what happened in a stationary application. And particularly, in this paper, we studied the effect due to temperature, as temperature has a negative effect on the efficiency of photovoltaics. So we studied this aspect when vehicle is moving and when vehicle is parked, and we estimated in some cases an increase of efficiency during the movement of vehicle, and a decrease of efficiency when the vehicle is parked, and some solution could be done starting from these studies. So we candidate this project to some European projects by making some partnership with some industry, from Landirenzo to Solbian and Mecaprom are three Italian industries. Solbian produces photovoltaic panels, Mecaprom produces powertrain and electric vehicles, Landirenzo produces some natural gas kit for cars. And the European program LIFE financed a project to produce some prototypes, 5 prototypes, to TRL9. TRL9 is the higher rate of the scale from 1 to 9. 9 means ready for industrialization. And also a joint venture could be done with the partners, and we are going to establish a new company between the partners, partners ranging from north to south of Italy. We can give this car both to the final driver, to the client, with a business to client approach. So in aftermarket, this is the prevailing way to diffuse this solution. But we don't exclude that some OEM could take this solution to apply at the end of line, so enlarging the range of the models without reconverting production lines, which are very expensive to reconvert. Another solution is for fleet owners. So the kit could be applied to the ecological reconversion of car fleets owing to private or public companies. This proposal has received a large attention on the media. There are actually videos in many languages. One of these has resulted on the top 10 world videos in 2016. A movie also has been run with this car recently. There is a good willingness to pay from some survey made some years ago, and also we were quite surprised that a significant number of people considered the photovoltaic panels like a green icon. So they like the photovoltaic panel irrespective of the usefulness. And we also made some business plan to estimate the economic benefits in terms of market, in terms of return of investment of a company which could produce this solution. This is a short video of the first prototype within the movie Asphyxia. The first prototype could demonstrate the feasibility. Then these are some figure of the new prototypes which are being developed. New wheel motors with brakes integrated within the wheel, some new flexible photovoltaic panels, an upgraded battery, vehicle control, more modern vehicle control. And they were mounted on a Volkswagen Polo some months ago, and now we are mounting them on a Seat Ibiza. We have developed an advanced vehicle control unit, in this case using CAN bus interactions, so a very, very modern approach to control. This is some first video of the Volkswagen Polo in Biella. We are in the pandemic period. We can see we have and we are also developing a monitoring system which touches to assist the driver with a BeagleBone board using the Bluetooth technology. This is some picture of the BeagleBone. And this is the support produced by 3D printing. Then we also worked on the software. We are going to analyze out of road tests by using the data from CAN bus with some software. This is the software used for the real-time approach. Is developed with a producer-consumer approach. And this is some sample of the data taken from a CAN bus and transferred to the Bluetooth receiver. Then we also developed some other tools in MATLAB in order to analyze in a systematic way the results from the cars. And we are working. This is the validation of the data taken by the CAN bus master by some commercial tools and some sketch of the data taken on the first test of the engine. So we can go to the conclusion. Conclusion is that mass transition to electric vehicles is the future, of course, but it's not behind the corner. While hybrid vehicles may represent a valuable solution in the short, medium term, but massive substitution of conventional cars to electric and or hybrid is not affordable for many users, is not the most sustainable option in the short term in an LCA perspective. While the reuse and the conversion of existing vehicles, both by hybrid or by electric conversion, may represent a good short-term option with a portfolio of a possible solution. The Italian Parliament has approved now a law allowing the conversion in hybrid to, like India did some years ago. And we can say that solar hybridization has some advantages with respect to full electrification in terms of range and in terms of recharging. And the EU project LifeSave, aiming at the development of prototypes for industrialization, is now at an advanced stage, and the access to market is planned in the 22, possibly at the end of this year. And this is the website of the project. And I thank you for your attention.
Thank you very much, sir, for sparing your time for today's webinar. It was indeed a very, very informative session. There are a few questions posed by the audience. I would like to read a few of them.
Yes.
The first one is, degree of hybridization is so far less, as you quoted, 0.2%. Is it too less or satisfactory?
Degree of hybridization is limited by the power that we can add to an existing car, because there are some limitation in terms of weight to add to the real wheels, and also to the power that we can add, and this is the limitation to the degree of hybridization. I say 0.2, 0.3, but this ratio is maybe enough for using the car in at low speed, relatively low medium speed in urban driving. I don't exclude that if the power to weight ratio of wheel motors will improve, this the ratio may increase in next years.
Okay, sir. Next question is there considerable future for hybrid vehicles?
Can you repeat, please? If there
is there a considerable future for hybrid vehicles?
I think yes, because we have to start from the actual limitation of electric vehicles, and actually the electric vehicles have a range which is not comparable with the conventional vehicles. And let's consider also the fact that when we talk about the range of electric vehicles, we just consider the power requirement for driving. We don't consider the power and energy requirement for climatizing the vehicle. There are countries where it's cold or it's quite hot, and we need a large amount of energy to keep the temperature controlled. In this case, the range of an electric vehicle may be the half of what is declared. So this is a serious problem. And so I think there is also the fact that not all people have the possibility to recharge an electric car at home, or have some facility to recharge the electric car. So I think this is the reason why the hybrid vehicles may have a future.
Okay, sir. So next question is, do we need to improve road conditions too?
Can I read the question, please?
Yeah, the conditions, how should be the conditions of the roads?
The rules.
The roads, sir.
We need to improve the road condition. Of course,
Yes.
I think this is a requirement for every kind of a vehicle, because all vehicles have roads. If road is not good, every kind of a vehicle may have some problem. It's not a specific problem for the hybrid vehicle. Of course, a good priority is to have some good roads.
Yes, sir. The next question is, how better is the durability of solar cars than the fuel cars and the cost reduction?
Durability of a solar car. Speaking about our solar car, if you speak, our solution is not just a solar car, it's a solar hybridized car. So the solar panels for stationary application have a duration of almost 20-25 years. So they duration is maybe greater than a car, and then there is the problem of the duration of the components, the electric motors and the battery. I think the most critical is the battery. But this problem is being afforded by a lot of people, because battery is a critical component of electric vehicles, hybrid. And there are solutions allowing substitution of battery, that allowing to have a significant life, I think. Cost reduction. The cost may take into account also the possible incentives. In Italy, in Europe, and I think in many countries, there is a policy of giving incentives for ecological vehicles. And reasonably, this kind of incentives could be given also for this solution, because we achieve the same performance of an ecological vehicle. In this case, we estimate that the cost of our solution in the Italian market may range from 2,000 to 4,000 to 5,000 euros, depending on the sizing of the battery. The largest the battery is, higher the cost. But in this case, we may have some performance of a plug-in hybrid. So the value of the car is greater.
Okay, thank you. So one more question. To what extent charging is challenging?
Charging is challenging. Charging may we may charge the vehicle by external net or by solar panels. About solar panels, I've demonstrated, I've showed that the ideal amount of energy may reach 2 kilowatts per hour, but even more in a sunny day, while the average consumption of a car in urban driving, in a typical urban driving, may be almost 10 kilowatts per hour. So in this case, the percentage of the solar contribution may be from 10 to 20%, which is quite significant, considering that it's green and it's free.
Yes, sir. Next question is it relevant to India? What factors decides this?
is relevant to India. I think in India there is the sun. I think the most driving likes like urban driving at moderate speed. So I think yes. And I also think that India has a lot of existing cars. I don't know how much money is available now to dismiss all these cars to convert in electric or a hybrid. Maybe it's a lot of money. I think that India, like every country in the world now, will have some economical problem due to crisis. So I think it's also for India, it's a good solution.
Okay, so next question. In the end, we are modifying an existing car, which is a proprietary product of a manufacturer. What are the regulatory challenges?
Allora, well, this depends on the laws. We may refer to the law for electrification. The law approved in Italy and in Europe for car electrification says that the transformer is not obliged to ask the producer of the car for admitting the transformation, but it must of course comply with some rules, and I think the same may happen for hybridization. So this transformation may respect some technical parameters that will be defined by laws, of course.
Okay, so is it good to construct a new hybrid car or reconstruct an old one?
By personal considering that at this moment today this solution is not yet on the market, so we may speak out in 1 year when the solution will be on the market. It depends on the if the government would give the benefits for this solution may be much less expensive than buying a new hybrid car. And I think that the government should consider that in implementing this solution may help the nation and the world to reduce the impact on energy consumption and CO2 emission. We demonstrate that by an LCA approach, this solution is more sustainable than others. Also by personal, it depends also how old is your car. If your car is very, very old, maybe it's better to change it.
Yes, sir. Sir, is solar energy sufficient to run an AI-equipped self-driving car, as there will be many sensors and other technicalities involved in the AI-equipped self-driving car?
Artificial intelligence and sensor usually don't use a lot of energy. They have some cost. There are some cost issues and some safety issues for using this solution, but not so much in terms of energy. So I don't think is relevant. The most of energy is required for traction, not for the additional things required for sensoring and so. But the optimized use of this car also require, for instance, good intelligence. For instance, know if tomorrow there is the sun or not. So I may decide to charge my battery this night or charge partly my battery because tomorrow there is the sun, and so I may have some free energy. So there is a lot of intelligence to be incorporated in this kind of vehicles too.
Okay, sir. So thank you so much for patiently answering all the questions. As
I
we
hope
come to the
my
end,
answer could be could be good.
yes, sir, of course.
Hmm.
So as we come to the end of the webinar, I request Dr. Bindu A. Thomas to give the concluding remarks about the session.
Mhm.
Very good evening, Professor. Good evening to all the participants out here. I'm really happy that we have today with us Professor Dr. Gianfranco Rios, Professor at the Department of Industrial Engineering, University of Salerno, Italy. He has given us such a informative and a very revolutionary research thought that has already been implemented by him and his team, and he also showed us some of the glimpses of this solar hybridized car, which I think for lot many researchers out in our country, it will give us a lot of research problems which they can look into. It could be about the energy, it could be about the battery, and it could be about to improve the power and a lot many more aspects. He also touched upon various aspects like the thermal effect of the PV panel on the car, which as I was listening to his talk, I also understood that we'll have to check whether there is any thermal effect for the car and also for the person sitting inside the car. So this is an important research that he's taken over. And he also has integrated Canvas for the advanced monitor system to assist the drivers. Use of CAN data for understanding the the analysis of the data that is happening, and then he has also looked at the perspective of climatization, which is very important for the hybrid car vehicles, and he has brought in the thought that one may not look at the electrification or hybridization of the cars only to understand the power requirement, but also look at the climatization aspect, which generally is forgotten. Thank you so much, Professor, for bringing in so many thought-provoking research ideas in to this whole understanding of today's webinar. It was indeed very, very useful and informative, and we are able to understand the current research that is happening in your country at Italy, and of course in your lab. Wonderful to have you on here this evening. Thank you, Professor.
It was I was very, very pleased and honored to participate in such prestigious webinar. And
thank you, Professor. It was a wonderful speech. It was appreciated by all the participants. We request all the participants to switch on the video. We can have in snap.
Goodbye.
Okay. Bye, Professor. Kishore, sir, any doubt, sir? Any?
Certainly the way ahead, I think the whole world would see vehicles to transform for impacting the global war, minimizing fossil fuels, and that is certainly the right topic to discuss. And today's news about climate change, and we all need to. The government also has increased the fuel price. This is attended by worldwide attendees, and Dr. Gianfranco has done a wonderful job explaining and clarifying to us.
Thank you very
much,
much.
sir.
Thank you very much. Thank you.
Thank you, Kishore sir. Thank you, Dr. Bindu. Now I would like to
Request
propose.
participants, please switch on the video.
Now I would like to propose vote of thanks. The essence of all beautiful art is gratitude. I, Dr. Maina N, on behalf of IEEE Mysore subsection, take the privilege to propose the vote of thanks on this occasion. I convey deep regards and hearty thanks to the resource person of today's webinar, Dr. Gianfranco Rizzo, for accepting our invitation to deliver talk on ecological reconversion of cars, the case of solar hybridization, and sharing his knowledge and research experience. Thank you so much, sir. I'm
Thank you to
extremely
you.
grateful to Dr.
1
Extremely
minute,
grateful.
1 minute, madam.
Yes.
To virtual momentum, and thanks from us, and we thank you for spending your valuable time and information to us. Thank you.
Thank you. Have a good night. Have a good night.
Good night, sir.
Thank you. Good night.
I'm extremely grateful to Dr. Bindu A. Thomas, Chair IEEE Mysore subsection and Professor Head, Department of ECE, VVIET Mysore, who has been a pillar of support in organizing this event. Thank you, Madam. Heartfelt gratitude to Dr. Parmesh Achari, Chair-elect IEEE Mysore subsection and HOD, Department of TCE, GSSIETW, for the support and guidance he has extended to all of us. Thank you, sir. I wish to express my sincere thanks to Dr. Sudarshan Patil Kulkarni, Vice Chair IEEE Mysore subsection, Dr. K.A. Radhakrishna Rao, Secretary IEEE Mysore subsection, and Dr. Archana NV, Treasurer IEEE Mysore subsection, for their support in conducting this event. My deep regards and thanks to all the EXICOM members of IEEE Mysore subsection for their support and encouragement. My special thanks to all the coordinators and volunteers for their support and teamwork in conducting this event successfully. I convey my thanks to all the participants for making time and attending this webinar. Hope the knowledge gained from this webinar will lay path to many young minds. I once again thank each and everyone present here for making this event a grand success. We hope to get the same support and encouragement in all the future initiatives of IEEE Mysore subsection. Thank you one and all for your patient listening. Have a great day. Kindly fill up the feedback form provided in the chat box to get your e-certificates. Thank you so much.
solar